Good morning, everyone. I am R. Monica Lakshmi, working as an assistant professor in the Department of Computer Science and Business System in RMD Engineering College. Today, we are going to see about I/O transfer. So, what is an I/O transfer? We'll start with an example. So we have n devices, like we have IO device, we have memory, we have processor. So all the hardware components are connected through an interconnection network. Okay. So whatever request we are giving from from our side, from the user side. Say for example, when a Word document is open, I'm typing some alphabets. So the whatever alphabets I'm typing, it should be displayed on the screen. So for this, whatever we do from the user side, it has to be processed by the processor. So whatever we type, that request will be, so an IO request will be given to the processor, and the processor will send a response, like the particular alphabet can be displayed in the screen. So based on that only, that alphabet is displayed on the screen. So this is going to be the IO transfer, how the data is being transferred from the input output, that is from our side to the system through an intermediate thing. So that intermediate thing is known as my IO module. So the peripheral devices are linked to the IO module, and this IO module through the system bus. So what is system bus? It has three important terms. There is control line, data line, and address line. So through this bus only, whatever data can be exchanged between the hardware components. So the hardware components may be memory or processor. So on this side, it may have the IO devices. So through the system bus only, it is going to be done. And before going to the system bus, the IO devices will be connected to the IO module. So to the IO module, the system bus is connected, and to the system bus, our processor and memory will be connected. Okay. So this is going to be my generic model of an IO model. So whatever request we are giving from our side will go through the IO module and will pass through the system bus and reach our memory or the processor. So we have three forms of transfer. One is programmed I/O, the second one is interrupt-driven I/O, and the third one is direct memory access. In today's session, we will see about programmed I/O. So this is the diagrammatic representation of the programmed I/O. The CPU is processing some instruction, and it interrupts, not interrupt, it is encountering some kind of I/O related operation. So what happens? It makes it can be an I/O read or an I/O write. Okay, so it makes a request. So this is going to be my intermediate IO module. And what happens from this IO device? So it has requested for IO read or IO write. So what my IO device will do is it request for the bus. Okay, once the bus request is given, the IO device sends the valid data. What it sends? It sends the valid data that is requested by the CPU. So, and here in between, there is the IO module. It has two important terms. One is data register. The second one is the status register. So the data register is going to hold the value that is being sent by the IO device, and the status register is going to have the flag value. So when this flag value is set, it means that the data register is filled with the data, and that particular data can be used by the CPU. So this is the concept. So when this makes an IO request, what happens? My IO device will send a bus request, and once the bus request is got by the IO device, that is bus arbitration. Yes, I told you. Bus arbitration is getting the bus. So maybe some other IO device can be having that bus. So it requests for the bus, and once the bus has been got to pass the data, it passes the valid data, and what happens? The status register will be set. Okay, it will be set. The flag value will be set to 1. It means that the data is available in my data register. Now what happens? The CPU will take the particular data, it processes and return back the result. Okay, the data will be accepted. Okay, so this is my entire process. But in programmed IO, there is one disadvantage, like the CPU was doing one set of operation. Okay, in between it was interrupted. In between it had an IO based that it was encountered with an IO operation. So in between it made a request to this IO module. So until the status is set to 1, until the data register contains a value, the CPU will wait. Okay, it is going to wait until the status register value is set to 1. Once it is set to 1, it takes the data and it uses it. Okay, so here what is the concept is the CPU, whatever the task it is doing, it was doing earlier, will be stopped, and it waits for the IO request to be processed completely. After it is processed completely only, the CPU will start its further process. The process that it was doing earlier will be started after that only. So this is the only disadvantage in my programmed IO. So CPU is going to be waiting until my status register is filled, that is it is set to 1. That is my data register. If it has a value, if the particular value is present, it will be set to 1. So until that, this particular CPU will be waiting. So this is one disadvantage in my programmed IO. So to overcome this disadvantage only, we go for the interrupt driven IO. So that we will see it in the next class. So today we have seen what is IO, what is an IO transfer, and in that one technique we have seen there is programmed IO. So this is my programmed IO transfer. I hope you all had a good understanding of IO transfer in that programmed IO technique. Thank you all.